In this video for 3D geometry, we will be talking about two topics. One is the angle bisector of two planes, and one is line of intersection of two planes. Both of the topics are important, especially the line of intersection of two planes, and I will be spending some time on that. Angle bisector of two planes is a very easy topic, just sort of like something you should remember while you are preparing for JEE. And I will just give you the formula. I won't even be doing a problem on this, but I will be spending some time on this because I think this is a relatively important topic. Okay, so what is, so let us say we have a pair of plane and you have to find an angle bisector. So that initially, so this is the angle bisector, and a plane which is the angle bisector of the two planes. So this angle is the same as this angle, and you have to have been given equations for P1 and P2, and you have to find this equation of what it would be like. So now if you think about this, the easiest way I think about planes is actually using a notebook. So I will always recommend you can do that if you are a little confused. So now this is, let us say I have a plane like I have two planes like this, again they are infinite. So let us say I have two planes like this, and then one angle bisector would be something which is bisecting this angle, but this plane can also be extended into this direction here. So there can also be an angle bisector of this angle between the two planes. So there are always two angles, one is acute, one is acute and one is obtuse. So you can find both of equations for both of the planes, and the way you do it is very simple. So I will just describe how you find the equation of both kind of planes. Okay. So again there are two angles, obtuse and acute. How will you find angles? Just take the dot product with n1 and n2, you will get an angle either obtuse or acute. So one would be, if there is another angle, you can just subtract 180 minus that to get the other angle. Alright. So let us now let us say we have equations like, I mean this is just the way it has been, this is just literally almost like remembering that how you should do it. So I am currently writing D1 here, so please take note of this, and generally I write D on the right hand side, but this time it is here. And whenever you get something like this, ensure D1 and D2 are greater than 0. Let me clearly write D1 greater than 0, comma D2 greater than 0. Ensure this. So whatever equation is, take this constant to the left hand side and multiply by negative if the need is to make this greater than 0. Once you have ensured that, then check if A1 A2 plus B1 B2 plus C1 C2 is greater than 0. Then check if A1 A2 plus B1 B2 is greater than 0. If it is greater than 0, then A1x plus B1y plus C1z minus D1 by root of A1 square plus B1 square plus C1 square is equal to A2x plus B2y minus D2 by root of A2 square C2 square will be the this would be the angle, but this will be the angle bisector of the obtuse side. And similarly the whole thing, let me just write it down so that there is no confusion. That should be the angle for the acute side. Okay. So and with a negative sign in front. So this is only when A1 A2 plus B1 B2 plus C1 C2 is greater than 0, and if it is not greater than 0 and vice versa otherwise. So the signs would reverse if this is less than 0. So vice versa if, or I mean if it is not clear, probably just say opposite if A1 A2 plus B1 B2 is less than 0. Okay, think like this. So whatever the sign of A1 A2 plus B1 B2 plus C1 C2 would be, that would be the sign of the obtuse side. So that is how you can remember, that is how I remember. But you again have to ensure D1 is greater than 0 and D2 is greater than 0. So it's a very it's not a very conceptual thing. I mean, I can explain to you how this equation was derived. It's not hard to see. This is actually similar to what you probably have already done in the chapter of vectors, where there was the discussion of angle bisector of two angles. But I mean, that's not the important point here. The important point here is to, if it comes and if you are being asked, just remember this thoroughly. It's literally like just being careful with signs and calculations. So I am not doing a problem for this. You can do very easily construct two planes and then just find the angle bisector. I think it's pretty straightforward. Just you have to remember the formulas. Okay. Now let's go to the next part, which is a very interesting part, is the line of intersection of two planes. So let us say you have two planes P1 and P2. So what is the angle, what is the line of intersection of the two planes? That is the line which is this line. This is the intersection of line of intersection of two planes. So again, if you have a notebook, then the way you think about it is that if you have a notebook like this, then this line is a line of intersection. So you just take a notebook and look at this line, and this is your line of intersection. So how would you find the equation of the line? So if you know P1 and P2, and the question would be, how would you find this line L here? How would you define this? So what do you need to define a line? You need a parallel vector. So with P1 you will have one n vector, n1 vector and n2 vector, and now you need a point here, a vector of a point, and you need a parallel vector. Okay. So what is the property of this parallel vector? The property of this parallel vector is that it lies on both, it is parallel to both P1 and P2 planes, right? Because it is parallel to the line, and the line is in both the planes, so it is parallel to both plane P1 and both plane P2. So in other words, it is perpendicular to both n1 and n2, and as soon as I say this, it should flash into your mind that B vector is n1 cross n2. That B vector is n1 cross, I mean this is just something straight out of the cross product definition, that B vector is equal to n1 cross n2. And please you should recall the chapter of vectors. If you are forgetting, please always remember how to do that. So first step you will do is you will find n1 cross n2 for B vector, and the second thing you would do is find a common point, find point by putting one coordinate to be 0, putting one coordinate to 0. So I will solve the problem, so that will hopefully make it easier for you to. So the equation for P1 that has been given to you is x plus y plus z is equal to 1. So this is x plus y plus z is equal to 1, and the other thing that the other plane that has been given to you is x minus y plus z is equal to 1. Okay, x minus y plus z is equal to 1. So first thing we have to do is we have to find B vector. So what is n1 vector? That is I cap plus j cap plus k cap, and n2 vector is I cap minus j cap plus k cap. Now B vector would be I j k 1 1 1 1 minus 1 1, and if you open this up, it will come 2 I cap minus 2 k cap. Okay, this is what you will get, and you can check by taking a dot with both of them. This is 2 minus 2 0 and 2 minus 2 0. So this is a vector that is perpendicular to both n1 and n2. So this is the vector parallel to the line, and then you have to find a point on the line, which is how to find. So this was step 1. The step 2 would be, so we can put any coordinate to be 0. Let's put z is equal to 0 in both the planes. So what we are doing is we have to find a point. So we have to get the x coordinate, y coordinate, z coordinate, but there are 2 equations and 3 variables. So we are putting one coordinate to be 0. So if you put z is equal to 0, then you just have 2 equations and 2 variables, and then you know the point, right? So we have now x plus y is equal to 1 and x minus y is equal to 1. So if you, that will give you x is equal to half and y is equal to also half. So sorry, x is equal to 1 and y is equal to 0 actually. So this will become x plus y equal to 1 and x minus y equal to 1. So this becomes x equal to 1 comma y is equal to 0. So the point A is 1 comma 0 comma 0. So equation of line L is actually I cap plus lambda 2 I cap minus 2 k cap. Okay. So this line would lie in both plane 1 and plane 2, and you can also write it in the coordinate form. Let us just write it in the coordinate form also. So x minus 1 by 2 is equal to y minus 0 by 0. So that means y is equal to 0. So y minus 0 by 0 is equal to z by minus 2. Okay. So I hope that this made sense, gave you a good idea of what it means. So line of intersection, like a notebook, is a line common to both the planes. It is perpendicular to both n1 and n2. So it has to, the parallel vector has to be n1 cross n2, and then you can find the point by putting one coordinate to be 0. So this was the topic for angle bisector of 2 planes and line of intersection of 2 planes. The next video now will start mixing up line and planes and points and planes and things like that. So I hope to see you in the next video. I hope you enjoyed this video. Thank you.